Good, all right. Good evening, Mr. Thompson. Thank you very much for joining this evening. That's our mentor. Then I can see some of our mentees also, Abdul Rashid, Daniel, Barak, Audrey, and all right. So good evening, everyone, and you are welcome to the first class for this year mentoring section. All right, so welcome to lecture up and the third energy mentoring circle. For those that probably do not know what lecture up is, lecture up is an organization with a motto where we learn effortlessly. Uh,
Sorry, so please let me yourself and mute everyone.
okay, all right. So you're welcome to lecture up. It's an organization that trains students, young graduates, young professionals in the field of the engineering, especially energy. It's a training ground actually. A lot of times in our school, where we just get to learn some aspect of the field. But here in lecture up, we have the privilege of meeting people that have been in the industry, people that have the knowledge, people that are practicing the field, sharing with us, teaching us practical things that entails in the field. And at the end of the lecturer up circle, there will always be certificate, there will be quiz, there will be capture and everything, right? So this is the beginning of a great journey. Okay, let me introduce myself. Yeah, I'm Jonathan, and I'll be serving as the supervisor for this class. Then we also have our moderator here with us. I believe she has been introduced also in the chat group. That's Joy Ibrahim. So she will serve as the tutor for this class, and we have two mentors for this specific class. So that makes our class very unique. All right. So basically, it's a 1 month program, and this is going to be the third circle. Interestingly, I was part of the second circle as a mentee. So I participated in the last circle. That was the second one as a mentee. Then my class then was project management. Yeah, my class was the best then anyway. As you journey through, you will get to know about all call capstone project and competition. So the last circle, my class took the first then. So my class was the best. And I hope this class will be the best for this section. All right, so the mentorship is about the oil and gas. We'll be looking at introduction to the oil and gas, a kind of a comprehensive overview of the oil and gas. A lot of times we'll have heard of oil and gas, oil and gas, oil and gas. And a lot of times, our view about it might not be comprehensive enough. So many people now, when they hear oil and gas, the only thing that comes to their mind is money. Oil and gas. Some people does not even really know every stream of the oil and gas. But once they just hear oil and gas, money, money. Once you hear this person is working in oil and gas, the first thing that we just assume is that it's all about money. But of course, outside the money, there are the technicality, there are different sections of the oil and gas. Even before you can see the oil, there are different the drilling, the production, and every other thing. So this is what we'll be looking at in this section. And we believe that at the end of this section, we have a comprehensive view of what the oil and gas is all about, from the upstream to the midstream and to the downstream. We have an understanding of any companies operating, the IOCs, the international oil companies, the indigenous oil companies, and our national oil companies. That's basically what we'll be discussing. Technicality, then you find, okay, which one do I want to pursue? Will I love to work in the upstream? Will I love to work in the midstream? Will I love to work in the downstream? At the end of the day, everything is still petroleum sector. We have different sections, and there are technicalities attached to each of those sections. So this is basically what we'll be looking at: the overview and comprehensive overview of the oil and gas industry. Uh, we'll be taking attendance for each of these classes. There will be attendance actually, and here our attendance is actually very, very important. You take it very important because there's a percentage of attendance that you have to meet before you be qualified for your certificate at the end of the day. So please, let's ensure that we are punctual and we are regular, right? It's just 1 month and promise to be committed to that 1 month training. So it's essential that we ensure we turn up every day on Monday, on Thursday, and on Saturday. Our attendance is very important. Each day we take attendance and you don't know when we're going to take the attendance. So it's not just about, okay, let me show and leave, right? We can leave and we not take the attendance. And when there's no evidence, we explain tire, right? Okay, so attendance is very important. There will be assignments from our mentors. Please let's respond to the assignment. Each of those assignments will be graded. They'll be part of our continuous assessment. And there will also be an exam, not a big exam, not as big ahead, but there'll be an assessment at the end to ensure that we've indeed learned something. So please let's ensure that we're committed to that learning. It's quite very important. You never can tell where those knowledge will take us to, right? And this is petroleum industry, and even in Nigeria today now, we're expanding bit in the petroleum industry. So having knowledge about basis can help us in our interviews, and for those that are even practicing, it can also help us to further. Anybody there's nothing that when it comes to learning, like cannot attain the apex every day we are learning. So even for those, maybe there are people that are already in the industry, but this is also an avenue for you to learn more. For me, I'm practicing already as an engineer, right, in the oil and gas, but yet I'll still be here to also learn from people because we're all here to learn. All right, and I also pass the mic to our mentor so I can hear from him, can hear the instructions that I want to have, and advice that we love to give us and make us ensure we make our best use of the mentoring circle. So over to the mentor. Mr. Thompson, we'd love to hear from you. The instructions you would like to give the mentees, the advice you would like to give the mentees before start. Thank you, sir. All right, I don't know if our mentor can hear us. Let me repeat, sir. Mr. Thompson, we'd love to hear from you the instructions that you would like to pass to the mentees, the advice you would like to give them so that they can have the best use of these mentorship sections. So over to you, sir. You can unmute yourself, sir. I can't hear you.
Um, for this class, first off, I want to welcome each and every one of us, most especially my madam at the top, Miss FG, the Chief Ambassador herself. So, and uh, the moderator and the supervisor and the mentees, because without you, this class is not going to hold. And for this class, I want us to just make it as simple, as fair, and as orderly as we can. Our questions will be after the class, and during the class, if you're having any questions or any doubts, they just get a pen and paper, write it down so that after the class, you can ask your questions, or if there's any form of addition you want to add, you can, also let us know. Like I said in the WhatsApp, we as mentors are not just mentoring or teaching, but also learning. Because as a person, I believe that learning is a continuous process. So that's all from my end. I believe Miss FG also has one or two things to tell to us about.
Okay, thank you so much. You know you are the senior comrade. Good evening, everyone. Please, you can hear me right.
Yes, we can hear you, ma.
Okay, thank you very much. And sorry, I'm trying to shuffle all the classes. I need to be sure that they have started. So you can go ahead to address the mentees. I will leave the call, then join back in 5 minutes, just to be sure the other classes are set and good to go. So I'll make you the host automatically. Then once I join, you can make me a co-host. Did you copy?
Please, can you come again?
Yeah, I said I have to leave now to check the other
Oh,
classes if they are set.
all right,
Then I will
all
join
right,
back in the next 4 minutes. So I'll make you the
all
host. When I come back, you make me the co-host.
all right, no problem. So let's just get to know ourselves. So please, you can just tell us your name, what you studied, or if you're a graduate, if you're practicing. So if you're a student, your name, your course of study, and probably your institution. Or if you're practicing, yeah, still your name, your course of study, where you graduated from, and probably where you're working. All right, so who will start? So who is the first mentee that will start now? Just your name, your course, and where you graduated from. If you are practicing, you can let us know where you are practicing. Okay, should I call one by one? All right. Okay, let me call. All right. Abdul Rashid Yusuf Doma, can we hear from you? Just your name, your course, and your institution. And if you are practicing, can let us know. Abdul Rashid Yusuf, are you here? All right, let's move to another person. Oh, Mr. Daniel, yeah. Okay, let me just call the Daniel so I will not pronounce your name wrongly. All right, so Mr. Daniel, can we hear from you? Your name, your course of study, and your institution. Oh, sorry, everybody's. Oh, okay, sorry.
All right. Good evening, everyone. Once again, I welcome you all. And if you are hearing me, I will advise that we make use of the chat. Make use of the chat, and so that I can I can know that we are all following. And if I'm going too fast, if I'm going too fast, please let me know. Please let me know. So my name is Aletile Thompson. My name is Aletile Thompson. A graduate of Mineral Resources Engineering Technology and Petroleum Engineering Tech from Petroleum Training Institute, PTI. Uh, Currently a feed engineer slash a crude officer with Sterling Oil Exploration and Energy Production Company Limited. So that's basically uh, the few things about me. So thank you very much, IB. I think that's all.
Thank you so much, sir, for the introduction, and we're excited to have you. All right, I'm trying to see if I can unmute you guys from my end. so that okay. All right, you guys should try now and unmute yourself and speak. All right, yeah. So I think I can speak now. So just your yeah, all right, so your name, your
No,
course,
no,
and your
no, this
institute.
is too crowded.
Good evening, everyone. I don't know if anybody can hear me.
Yes, yes, we can hear you, patience.
Okay, so my name is Patience Musa. I'm a final year student in petroleum engineering. Sorry, studying petroleum engineering in HBU Bauchi. Yeah, so that's all about me for now.
Wow, wow. Thank you, patience. So all the way from Bauchi State. I believe you are preparing for your FYD, all the clothes, the jersey, and everything. All right, you're welcome. So you can pass the mic to another person. So who's going again?
Which one the person answer?
Who's going again? Just unmute your name, your course, and your institution. Can we hear me? That's our first test now. Only patients will be graded because the other people are not, they're not speaking. The mic is muted by the admin. I thought I've unmuted. Wow.
Okay, good evening. Good evening, sir. Good evening, everyone.
Hello, good evening, everyone. Please confirm if you can hear me.
Yes, we can hear you loud
Yes, we
and
can.
clear.
We can.
All right, my name is Abdurrashid Yusuf Doma, a graduate of chemical engineering. I work with Procon Energy as a junior process engineer. Thank you.
All right. Thank you, Mr. Yusuf, and you're welcome.
Good evening, everyone,
Mr.
sir.
Yusuf. Yeah,
Good evening, everyone, sir.
yeah, we can hear you.
Good. Okay, I am by name Hamzat Kodri Ayomide, a graduate of mechanical engineering college at Ladok Agitola State University of Technology, LAUTECH, currently serving my fatherland.
Wow. You're welcome, Mr. Yusuf. Serving your fatherland. It's not just your fatherland, it's our fatherland. All right, thank you very much. Next person.
Good
Good evening,
evening,
everyone.
everybody. Please confirm if you can hear me.
Yes, we can hear you.
Okay, so I'm Adebisi Victoria Oluwapelumi, and I'm a chemical engineering graduate of the Federal University of Technology, Mina. Yep, that's basically that about me.
Wow, wow. So we have two chemical engineers, we have one petroleum engineer. That's fine. Thank you very much. You're welcome. All right, next person. All right, we still have Shalom, we have Tulope, we have I think Adinel. We are still waiting for other people to introduce themselves. Then if you are not hearing from other people now, it simply means they just log in and probably they drop their phone and just drop their phone and they're doing different things. These are some things that we do. Yeah, even me sometimes I do that, just log in, just drop your phone somewhere and you go about your daily activities. Seems it will be counting that you're in the meeting. So that's why sometimes your mentor will just like to ask a question and ensure that people respond.
IB, some persons are saying they are still muted. Please, unmute everybody. Some persons are still muted.
I don't know. I've formatted every. All right.
Good evening, everyone. My name is. Good evening, everyone. Hello.
Yeah, good
Yeah,
evening.
we
We
can.
can hear you. We can hear you.
Good evening,
We can hear
everyone. My
you.
name. Okay. I am Mubarak Ikbadiola, the 400 level student of Nadoki Akintola University of Technology, Laut
Why
Tech.
should you get loud?
Currently in 400 level mechanical engineering.
God bless you.
Wow, you're welcome. So we have two mechanical engineers, we have
One
two
business
chemical engineers, and I think we have one petroleum engineer. That's interesting. All right. Next person.
Good evening, everyone.
Good evening.
Can you hear me?
Yes, we
Yes,
can.
we can hear you.
Okay, my name is Shalom Eze, a geology student of Federal University of Latvia.
Wow, thank you. All the way from Latvia. If I get you right, geology, right?
Yes, geology.
Geology. These are the real owner. These are the real owner of the oil and gas. So when you hear geology, they are the real owner. Most people are just
Mhm.
falling at the back, but geology are the real owner. All right, so you're welcome. So we have two
Like,
mechanical engineers, we have two chemical engineers, we have one geology, and we have one petroleum engineer. Right? That's fantastic. Is there another person that is yet to introduce his or herself? Is there another person that is yet to introduce his or herself? All right.
Good
Good
evening,
evening, everyone.
sir.
Good evening, everyone.
Good evening.
Daniel Aso from the Federal University of Petroleum Resources, FO, a 300 level student of petroleum engineering.
Wow. You're welcome,
Welcome.
Mr. So that makes
Yeah.
it two mechanical engineers, two chemical engineers, two
Welcome.
geology and petroleum engineers. Wow. So there's a tie now, two for these four courses. That's fantastic. All right, thank you very much, Mr. Daniel. Yeah, next person.
Good evening, sir. Good evening, everyone. My name is
Good evening.
Omolade, and I'm an HSC professional, health safety and environment. Hello,
Yeah, we can hear you.
I
can you hear
hear
me?
you, ma.
Yes, we can hear you.
I have introduced myself.
Yeah, thank you, Odupitsa Omalade. All right, HSC professional, HSC Health, Safety, and Environment. Yeah, so you're welcome. What I do for safety? Without safety, our operations will be stopped, right? So, in the oil and gas, if there's one thing that they emphasize most, something that they emphasize most in the oil and gas is safety. That's what they emphasize most, safety. That's why you start hearing things like two box meeting for every operations. Safety look like the most. Yeah, I don't use the most powerful anyway because they're always like the watchdog, right? Any small thing. Once you hear safety officer is coming, you compose yourself, your helmet, you ensure your helmet is on your head, you ensure your boots and everything because if safety catch you, right? They currently where I work now, if safety catch you, they can just snap you. When they snap you like that, if you're not careful, you receive query, right? So that's also one very important aspect of the oil and gas safety, right? Without safety, our production cannot continue. All right. Thank you very much. Is there another person left that is there to introduce his or herself? So once again, you're welcome to the introduction to the oil and gas. All right. Oh, let me introduce myself. Okay, yeah. I'm Ibitoye Jonathan. I graduated from the Department of Chemical Engineering from the University of Ilorin. Currently, I work as a feed operator in Sterling Oil Exploration and Energy Production Company. That's the same company with our mentor.
Are you
All right.
serious?
Yes, sir.
You are in trouble.
No, I'm actually a small boy anyway. I joined February. Yeah, I joined February. Maybe I finished my service December, so I just joined as speed operator, GET. So don't worry, me and our mentor will speak. We speak in
Don't worry.
camera.
We'll see. We'll see. We'll see.
All right. All right, sir. So if I will ask, is anybody I want to like, okay, what do you expect from the class? Let's just take, not everybody now, just one or two people. Can you just probably let us know your expectation, right? What do you expect during this class? What do you expect to learn? What do you expect to achieve during the mentorship circle for the introduction to oil and gas? What are your expectations? What are your goals? What are the things that you wish, okay, I believe at the end of this mentorship circle, I will have been this and this and this and this. So let's just take two people. Let's do like this: a lady and a gentleman. So just two people. Just share with us what you are expecting. You know, of course, why do you pick the oil and gas? What is your expectation? You know, that will also help our mentors to ensure that they meet our expectation. All right. So just a lady and a gentleman. So who's going? Just a lady and a gentleman. Should I call name? All right, let me call name. Okay. Just I don't want to call anybody's name, so I do not be as if this supervisor is hunting somebody. So what you just volunteer to let us just talk. What do you expect? What are your expectations? What do you wish to achieve during this mentorship cycle? Anyone? Let's the gentleman speak now. Let's hear from Mubarak. So what are your expectations? What do you wish to achieve in this mentorship cycle? Mubarak.
Okay, good evening, everyone. My expectation from this is to have the overview of what is oil and gas, because most of us we don't really have more knowledge about this oil and gas. Just the oil and gas. Anything oil and gas is money, money, money. So, and we want to know more about, we want to learn and unlearn. So that's
All right. Thank you, Mubarak. So Mubarak said, you wish to have a better understanding of the oil and gas, not just the money, 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 and the hyping, right? Just like I mentioned, a lot of times is the hyping. Once you see somebody working in the oil and gas now, what you just start thinking, wow, this person must have money, must have money, must have money. So after the morning, Mubarak wish to understand how the oil and gas flow, the complexity behind the different stream that are involved, how we get the oil, and aside that, why is it that it's oil and gas? Is it really the oil and gas that we get from drilling, out of water, like everything like that? How do they separate the oil and the gas from each other? You know, how is it that okay, about our petrol? How do we arrive at our petrol and everything? So this is what Mbarak wish to learn. All right. So let's hear from Milady also. So who is going? All right, let's hear from Patience. So Patience, can you share with us like what is your goal? What do you wish to achieve in this mentorship circle?
Good evening, everyone, once again.
Yeah, good evening. Patient, we can't hear you again. Kindly unmute.
Okay, hello, can you all hear me?
Yeah, we can just hear you now.
Sorry, my network is fluctuating. So I was saying at the end of this class, I would like to know more in the oil and gas sector, how it works, and the upstream and downstream too.
All
I
right,
don't know
thank
if you.
you. Yeah, we can hear you. So patient said one of our goals or our goals is at the end of the mentorship circle, she will have gained an extensive knowledge about the oil and gas, from the upstream, then down to the downstream, right? What happens in the upstream? Why did they even call it upstream, right? And I believe, all right, we still do a lot of our mentors will do justice to everything. Don't worry. So I welcome again, and I believe we learn a lot about the oil and gas. By the time we are done with this mentorship class, I want to start seeing people posting on their LinkedIn that, oh, after lecture of energy circle, I'm now happy to start my journey with Chevron. After, yeah, that's the goal anyway, right? After the mentorship circle, uh, Yusuf will share on his link. I just see Yusuf posting that, oh, he's starting with Seplat, Daniel is starting with Chevron, Mubarak is starting with Shell, Amaladi is starting with Aladel, Patient is starting with Total Mobile, Exxon like that and like that and like that, NMPC, NLNG, yeah. So that's the goal anyway, and I believe we'll get there. All right, over to our mentors. I don't know if you have anything to still share with us, sir.
No, no, not really, not really. Like I said, I just want us to keep an open mind, you know, keep an open mind and fully participate in the classes because, as we can see, the classes are just 2 hours per session, as about 4 hours per week. So that means in 4 hours, we want to do a lot of things in just 4 hours. That's for a week. That means we are having about 16 weeks or so. I mean, 16 hours for the month. So I just want us to keep an open mind, to learn. And that's all.
All right, so thank you, sir. All right, so if I will ask, does anybody want to even share what do you know about the oil and gas? Anybody? For me now, let me share my journey in the oil and gas. No, yeah, I studied chemical engineering. Technically, all of us want to work in oil and gas anyway. But the first time I had the opportunity of entering the industry was during my internship. Then that was 2023. I had my internship with Chevron then. So that was my first time entering the oil and gas sector. Doing the, what's it called now? Is it undergraduate internship? These are our TOS or IT, right? So when I got to Chevron, getting to Chevron actually, even the fact that it was an IOC, I saw money. When I mean I saw money now, I'm not saying that me, like, I'm not saying I was paid well or I was ahead, but I could see people and I could see cars. I remember now I was seeing cars, the kind of cars I've not seen in my life before. I was seeing it to Chevron in that their headquarters in Lagos. I was seeing the comfortable life we were living and everything. That day I told myself that no, God, I will make sure that I keep on pursuing that oil and gas. So that was my first introduction to the oil and gas then. So I spent about 4 months before I returned to school. Then I finished school 2024. Then 2025, I went to staff. I wanted to serve in an oil and gas was, our NYT of the thing is kind of complicated. So I ended up teaching. chemistry and physics in one very remote area, like that. So after I finished my service December, then I went back again to ensure I stand for oil and gas, and that is why currently now I work as a field operator. As a field operator now, what I'm just basically doing is we are working with some of these equipment like pumps, compressors. Yeah, these are basically what we work with now. So I work at, in a flow station. Basically, our oil, after all the drilling and everything, directly from the well head, these are the things that you still be learning, right? So after all the drilling and everything, the hydrocarbon, right, directly from the well head now comes to the flow station, right? So from the hydrocarbon now, what they get from the ground now, what they get as hydrocarbon now can contain oil, it can contain gas, and can also contain water, right? So what comes from the wellhead, the hydrocarbon now could is usually oil, gas, and water. So it comes directly to the flow station, right? In the flow station, we have series of separation set up. So there's something we call separator, and chemical engineers will understand better. So the hydrocarbons now, so we're already learning actually anyway. So the hydrocarbon now are these three elements now, the oil, the water, and the gas, they have different density. The water is the one that is most dense, right? So the water, basically, if there's water, there's oil, and there's gas, it's the water that will be under. Like the water will be under because the water has the highest density, then followed by the oil, then followed by the gas. So for an hydrocarbon now, you see the water under, you see the oil in the middle, and you see the gas on top. So when you enter the separation, there are, the way the separator is being designed, there's what we call inlet divider, there's what we call mist extractor, and when the separator is designed, the separator have three outlets, right? So once the hydrocarbon enters the separator and separation process began, there are three outlets. There's an outlet for the water, there's an outlet for the gas, usually situated at the down part, then at the up part, the outlet for the gas, since the gas is the less dense. All right. So basically now for my own in our own flow station now, the water goes to the water treatment plant. That from directly from the separator now, there's a line for the water. The water goes to the water treatment plant. Then gas goes to what we call ICF. It's a gas compressor unit. Then the oil goes to the oil storage tank. All right, let me start with the oil now. So directly from the separator, there are also other things like CSU, flash drum, which our mentors might decide to speak about, right? So the oil just comes to the we have what we call tank farm, oil storage tank farm. There are different lines. The ones I don't know if you've seen a tank farm before. So the oil enters very big tank farm, like where I work now. Okay, we have a lot of tank farms. Let me keep their information private, but we have a lot of tank farms. So the oil enters. When the oil enters, sometimes we don't have perfect separation. So the oil that is entering the oil tank farm will still have a little water. So we have to do what we call dewatering in the tank farm. After the dewatering now, who is disturbing our friend now?
IB,
All right. And we
IB, thank you.
okay.
Yeah, that is the whole class you've given today. So I don't know if I can go ahead to share my screen and maybe wrap it up with all what he has said. Can anybody hear me?
Yes, we can hear you, man.
Okay.
Go ahead.
Okay. Good evening, everyone. Please, can we put our hands together for IB? He did very well. I want to see the reactions on the chat box. I want to see a good reaction because he just gave you an overview of production from the beginning. Like we have never started introduction and he has gone to production. Thank you so much, IB. And once I share my screen, kindly confirm if it's visible from your own end. So So I'll be using two different course materials because I want this session to be a little bit robust compared to the normal one. I'll also upload some materials on a classroom. So you go over them and just read more about them and how they can further improve your understanding. So for this course, it's very important because nobody gets to really understand the industry except learning from the basic. And that is why it's very important that you understand what the industry entails before you go into the industry. It's not just about I want to work in oil and gas, I want to work in, but do you know what the oil and gas is about? What are our operations? What do we do? How do we go about our stuff? What and what are some of the challenges we face as producers? Are there any ways we are mitigating our plants? Are there any ways we are optimizing our operations? Are there any ways we are optimizing our operations? So I'll be using the first material here from Total. Please confirm if you can see my screen. Let me join with my smaller phone so that I can be sure that the screen is visible.
Yes, we can see your screen. Petroleum
Okay.
principle.
Yeah.
Okay, thank you very much. So special recognition to engineer Sati, a reservoir engineer from Total. So one thing give me a minute. So one thing I want to do is because I don't want to just come up with materials just like that. I want us to use renowned resources that are of great relevance to us, of great importance to us. So that is why I had to do some outsourcing and get relevant materials that will be of great benefit to us. For me, good evening, first of all. I'm Morgan Efejiro, and I currently have just 1 to 5 years experience in the industry. I'm the founder of Lecture Hub, and I will be taking you with my boss. My boss has more experience compared to me, and I'll be taking you on the introductory aspect of the course, while my boss here will take us through the drilling aspect of the course. So I brought these petroleum principles from Total, and credit to Total Energies and also to engineer Sati for this publication that was out there for me to be able to lay my hands on. So for this particular course, it's very important that we start with the basic. What is petroleum? What is the industry about? What are some of the challenges of the industry? Where do we come in? What are the simple definitions we ought to know that we're expected to have at the background, like expected to know from this class? So I'm not just bringing up course because I just want to present to people, but I want to bring up course that people will be able to understand and at the same time have a clear understanding of what the industry entails. Please, if you are with me, you can unmute and say I'm with you. So I'm sure I'm speaking with us.
I'm with you, ma.
Okay, thank you
Yeah,
very much.
I too, how are you?
Okay, thank you so much. So the presentation outline for today, we'll cut through what is petroleum. We'll talk about the chemistry of petroleum before we go further into geology. So this course will entail petroleum, geology, drilling, exploration, production, and finally marketing. So the oil and gas industry has a value chain that encompasses everything from the wellhead to the market. So for this outline, we'll go over to the definition of petroleum. What is petroleum? I know most of us must have heard of petroleum. Most of us must have seen petroleum and at the same time maybe feel how it looks like. If you are gone for conferences, they will be like, okay, this is petrol. This is how it is like. So I will just so petroleum is an hydrocarbon. An hydrocarbon is H and C, atom H and atom C, or let's say, sorry, element hydrogen and element carbon. So these elements comes together to form an organic compound that is referred to as hydrocarbon. So they are constituents of a material that is made up of primarily hydrogen and carbon, and they are bonded in different formats. So the hydrocarbon is where petroleum is originated from. So hydrocarbon and petroleum is not the same thing. Hydrocarbon is the father, or let's say the mother. Petroleum is the, let's say, the byproduct or the product of hydrocarbon. I would have loved to draw a chain, so let me see if I can draw something. So you can see my cursor, right? So this is the, okay, it's not showing. So let me see if I can use another one. Let me use ball points. Let's see. Okay, so it's visible. Let me see. I just wanted to draw something for us before, but it seems we may want to use another way. So let me just leave it like that. So like what I was saying, hydrocarbon is the father, petroleum is the child. Let me use that simple analogy. So the hydrocarbon is purely organic compound, while petroleum is naturally occurring. They are more like flammable liquids that are found in rock formations. All these rock formations, they are deeply buried in the subsurface, inside formations. I will show us a subsurface photo or a subsurface representation of how the hydrocarbon comes in place. So all this mixture that is mixed of hydrocarbons and at various molecular weights, meaning at various weights. If you have ever worked in the refinery, you will know that there are different weights. The heavier ones are usually at the bottom, known as the bismuth or the bitumen or the quota, like the one we use to make our roads. Those are more like very, very heavy hydrocarbons. So petroleum is naturally occurring. And when you bring out the petroleum from when petroleum is gotten from the hydrocarbon, doing refining of that petroleum using the fractionating columns, the distillation columns, all these now refine it into different aspects that we now use as byproducts in our everyday lives. So petroleum comes directly from the ground as liquid, and it is called crude oil. So crude oil is that black substance that comes from the pipe, like the subsurface pipe. I will look for a very schematic diagram and maybe a video, then I will upload it for us to just go and watch how it is like. So it's usually very, very dark. It's extremely dark. So that is just the introduction of the petroleum. Now we have the chemistry of petroleum, because we don't just want to talk about petroleum, more like the national citizens. We want to talk about petroleum as engineers, mechanical engineers, or as any profession you are. So we want to talk about it in a different way, not that everybody is like talking of petrol. If somebody asks you now what is petroleum, you can't differentiate between petroleum and what do you call it? Between petroleum and hydrocarbon. So it's very important that we have an understanding of this whole stuff. So we have 4 different types of petroleum chemistry, hydrocarbons, like they appear in different molecules. If you did chemistry back then in school, you remember your chemistry teacher was always writing double chain hydrocarbons, triple chain hydrocarbons with cross and plus minus, and all those stuff. So we have the alkanes. alkynes, like all those are different chemistry entirely. But the ones we'll be talking about properly are the alkanes. The alkanes are more like the plus two kind of molecules or compounds. So they are what we call the paraffins. And the paraffins are majorly saturated hydrocarbons, and they have straight or branched chains. So the primary stuff of this, the general formula is CnH2n plus 2. Chemistry tells us that if you want to know the name of the next element, if C is 1, H2n, if n is equals to 1, it will be CH2, that is H2 plus 2, that is 4. So it's CH4. Am I confusing anybody, please? Are you guys with me?
We are with you. We are with you.
Okay. Yusuf, are you with me? Am I confusing you? Shalom, are you with me? Am I confusing you? Daniel, any confusion so far? Anybody responding? Okay.
They are responding in the chat.
Okay, I just noticed. Okay, Daniel said understood. Okay, I'm with you. So very soon I will call us to speak out, not only using the chat. So we have to speak. I have to hear your voice on our recordings. So now, so for the formula, I will give us the first assignment. The first assignment will be, IB, please take note. The first assignment will be write down the alkanes from when n is equals to 1 till when n is equals to 10, and tell me the names, like, is it butane, is it propane, is it ethane, is it pentane? So I would need that assignment. This will be your first assignment. Ivy, please take note. Then we'll go further to the cycloalkanes. These are more like the naphthalene, the heavy hydrocarbons. All these ones, they have one or more carbon. So one thing about the petroleum chemistry is the more the carbon rings in a particular compound, the higher the amount of carbon in that system. If we are talking of cleaner energy, pure energy, greener energy, it's because we are trying to look at the most cleanest form of energy that has the least number of carbon. We don't want carbon to be so much saturated in our systems. So that is why we look for the most cleanest. That is why if you have ever listened to the energy transition, people are promoting CH4, which is methane, because it has the minimum number of carbon in its own chain. So the cycloalkanes are purely naphthenes that are saturated hydrocarbons with one or more carbon rings to which hydrogen are attached to them. So with this now, their formula is different from the one of alkanes. Then we'll move over to the one of aromatic hydrocarbons. All these ones are more like 6 carbon rings, like benzene. Benzene is having a shape of a diamond. If you are drawing the formula for benzene, is more like having the shape of a diamond. Sorry, the light is a little bit challenging. Then we'll move over to the asphaltenes. The asphaltenes are primarily carbon, very, very heavy, extremely heavy. All these ones are those ones that we use for our quota, for our roads, very thick hydrocarbon. And they have traces of vanadium and nickel. So the formula for this one is just C ratio H. That is the amount of carbon ratio the amount of hydrogen. So we'll go over to the next aspect of this presentation, and that we have to do with will have to do with the more like the history of this energy stuff we are talking about, the history of the industry, how the industry came about, and what are what. So this is purely geology, because geology tells us the time scale of events. Following how the industry came about, back then they were like, okay, the earth was one piece. From the one piece, the earth now divided into different segments. That is why Africa is divided from the other continents. We have Africa, we have Asia, we have the other continents that are divided, more like the 9 continents that are divided, because there was a big bang. The scientists back then said, due to the Big Bang effect, something happened. An asteroid hit the dinosaurs that were once on the planet, and the dinosaurs went into extinction. So the extinction now resulted into fragments of the planet. So the planet got divided into different geo units, or let me say geo units. So with all these geo units now, the story of the industry now began 500 million years ago, like 5.4 billion, according to geology, in terms of the lifetime of the earth. So the earth is very, very old. Using the geology time scale is very old. And that is what geoscientists believe the earth to be, as old as. For avoidance of confusion, I wouldn't want to go into the geology time scale, because the geology time scale has different classifications. It has the eons, era, epoch, period. Like, it's different, it's categorized differently, that compared to how a petroleum engineer would want to read or understand the time scale for the earth. So I'll be moving further to the history of the industry. So the petroleum system has 4 elements. When we talk of elements, we are talking about things that helps us to propagate the oil and gas industry. All these elements are things naturally put in place by God. Yes, I would say it's by God. Naturally put in place for the origination, accumulation, migration, and also the trapping of petroleum, like the trapping of hydrocarbons. So I will stop this screen, and I will go over to the next screen so that I can. My laptop is hanging. I don't know why it's making the delay. Okay, so I will go over to the next slide, because I want to give us the introduction of the industry in terms of geology. Sorry, let me stop sharing so I can reshare. My screen is a little bit sluggy. Okay, once my screen is up, please let me know. Okay, is it visible now? Can you guys see my screen?
It's loaded. Yes, it's
Has
visible
it
now.
come? Okay.
Yes.
Okay, thank you. So let me share the other slides so we can go ahead. Okay, so for the like what I said earlier, the petroleum system is made up of four elements, and the elements are the source rock. So you write it down, it should be in your exam. So what are the elements of the petroleum system? So we have the source rock, we have the migration pathway, we have the reservoir rock, and we have the seal or the trap. So this four stuff makes up the petroleum system. Now let's take a look at this picture, for example. Now we can see that this is more like an illustration of the subsurface. This is how the subsurface is like in the industry. This is how we most times assume the subsurface to be like. So you can see my cursor, right?
Yes.
Okay, let me increase the size. Okay, I don't know how my screen is a little bit slowing me down. Okay, so I wanted to use, let me use this color. Okay, yes. So this part here that I'm trying to denote is the source rock. So the source rock is the origin. This is where the hydrocarbon is being formed. This is where the hydrocarbon is being formed. So when somebody asks you, where do we get our hydrocarbon from? We get it from the source rock. So it's the source rock that is the host of the hydrocarbon, is the one that produces the hydrocarbon. And an example of a source rock we know in the industry is shale. Shale is a source rock that generates hydrocarbon. Now, this is a cap rock. A cap rock can also be seen as a trap. A cap rock is impermeable, meaning it does not allow fluid to pass through it. So the cap rock automatically seal up entries or any exposure areas where hydrocarbon may probably want to leak out through. Then we have the reservoir rock. The reservoir rock is where the rock is being stored. Sorry, not the rock, where the oil or the hydrocarbon is being stored. So the reservoir rock is where people actually go, the oil and gas engineers actually drill from, not really the source rock. They drill directly from the reservoir rock because as time goes on, the hydrocarbon that was once in the source rock must have migrated laterally or upward from the source rock due to earth deformation. The earth deformation could be the movement of plates, the movement of boundaries within the subsurface that will lead to it degenerating or forming a new layer. From this point here, there is a new layer here because it has formed a fault. For the fault, we have the upthrown. I don't want to go too technical. Oh God, don't worry. Let's take it gradually. So we have, let me just take it gradually so that I don't confuse people. So we have the cap rock, like I told us earlier, the cap rock is to prevent migration or yes, migration of the hydrocarbon. Then we have the oil. So this oil now is going to flow through the migration pathway to the reservoir rock. The difference between the source rock and the reservoir rock is that the reservoir rock is permeable and it has porosity. Permeable means like your sponge can absorb water, it can hold water. And it's porous, meaning your sponge has pore spaces, it has holes inside that oil can be stored in them. But the source rock is not porous and is not permeable. It's just permeable, but it's not porous. How do I explain this stuff? Oh God. Please, if I'm confusing you, just try to call me back. But if I'm not confusing, you can always give a thumbs up. Then I will be sure that, okay, you guys are following me. So for the source rock, like I said, it does not have porosity. Why the reservoir rock has porosity? So this stuff denotes the rig. The rig is where we carry out the proper drilling to the subsurface and down to the surface, which is a surface equipment. So I'll move further to the formation. So we were told, based on history, that hydrocarbons are formed as a result of the dead, decayed animals that we once had on this planet Earth. And all these dead, decayed animals were more like the dinosaurs, the swans, all those animals that lived for a very, very, very long period of time. And all these things were proposed to have what we call the hydrocarbon potential, either gas or crude oil. So over geologic time, the organic matter, let me go back to the previous slide so we have a trace. So like what is documented here is, in ancient seas, plants, animals, and microorganisms abounded. So it was during the death of all these dinosaurs that all the part of the dinosaurs had to be buried in the seas and down surface, like the subsurface. So like what is stated here, so when they died, they sank to the bottom of the sea, where they usually become a source of food for scavengers. Then in circumstances, like in some certain circumstances, the regions that were highly acidic or lack oxygen, if you know the oxygen is not in an environment, it's deoxygenated, like there is no oxygen, so there is proper decomposition. So the remains of this dead organism rather did not fully decompose. So where there is no oxygen, there is a impartial decomposition rather. So all these organisms did not fully decay because of the lack of oxygen. So they mixed with our silt, our clay, that are more like sandy aspects from the subsurface, from on the surface or in the ocean, and they formed what we call algae. Algae are all those things that now later produces all these things that we are celebrating as hydrocarbons. So they are the remains of zooplanktons and algae which settle to the sea or lake bottom in large quantity under Anozoic conditions, meaning no proper oxygen. And they formed into what we call the coal. So coal is more like the household name. So it's from that coal that there was digenesis, catagenesis, that led to the different kinds of hydrocarbons that we have. So over the period of time, when there's a high level of heat and pressure, it is known as digenesis. Then they chemically change. So from digenesis, we now produce kerosene. So from the kerosene is now found in various oil shales around the world, and then with more heat into liquid and gaseous hydrocarbon in a process known as catagenesis. So catagenesis is more like a process that leads to the formation of gas. Now, this is more like an illustration of the environment. This is an environment where the substance. Okay. So let me wrap it up for you, then take further questions. So this is more like the environment. So all these are the marine environment, more like the organic. These are the shells. Then after a long period of time, sediment covered all these shells, all these body materials. So sediment covered them, and after sediment covered them, And after sediment covered them, the earth was still moving because the earth moves. Actually, the earth moves. There's different factors that affect continental drift, that affect the movement of silt, sand. If you know, rain usually falls, and when rain falls, the environment changes. Like the water just carry the sand from one location to another destination. So that is to tell you that the earth is constantly in a moving position. So with time, all this stuff were buried and decomposed into the subsurface. And from the subsurface, I will not go into more geology, so I don't confuse us. And from the subsurface, we add different classification of the depositional environment. So for the depositional environment, we have the marine depositional environment and we have the continental depositional environment. The continental are more like surface lands, while the marine are more like deep water. Then we have the transitional. Transitional is the phase between the continental, which is the land, and the marine. So let's take it that way. So now the accumulation of hydrocarbon is for the accumulation of hydrocarbon, three things ought to be involved. The cap rock has to be there, the reservoir rock has to be there, the source rock also has to be there. So, and a trapping system should be there to further enhance the movement or the migration of the what do you call it? The migration of the hydrocarbon from one source to the next, which is the reservoir rock. So I'll stop here. Is there any question for me? Any question? Omolade, any question? Charles, any question? Daniel, Shalom, Tolulope, Quadrille. I will get in the materials after the class. Yes, I will upload it on the Google Classroom. You can have access to it there. Okay, you're welcome. Shalom, do you have any question? Let me unmute everybody because I don't know why you guys are not speaking out. Okay, I just got a question, how gas is being formed. Okay, so before I go into how gas is being formed, let me share this one. Okay, so like I said earlier, gas is formed in a way different from crude oil. So for the gas, it's more like catagenesis compared to diagenesis. So the catagenesis is more like an increased level of heat, because anything beneath the subsurface, there is high or there is intense heat and intense pressure. As you go downward into the subsurface, you have a higher level of pressure and you have a higher level of temperature. That is why the drilling engineers, whenever they are drilling from the subsurface, if you have witnessed any of the oil and gas movies, the drilling engineers, they kind of drill with safety equipment known as the blowout preventer in charge, so that in cases where there are a sudden backflow of pressure to the subsurface, the equipment automatically hold down the pressure in place. So the further heat of that, let's just say when more heat and pressure is acted on the kerosene, the kerosene produces the gaseous hydrocarbon in the process of catagenesis. Is that one clear? Is it better? Is it better, Molade?
But I don't know if you can almost everybody so that it can be easy for them to communicate instead of typing.
Can you hear me? You say what?
Right? Can you almost all of them so as we can communicate faster instead of the typing in the chat box?
Okay, let me see if I can unmute. Okay, can you hear me now?
Yes, ma'am.
Okay, yeah, so like what I was saying, just saw another question, and the question is more like how I think how do Joe okay, let me go further again. My question is I need some explanation on Reservoir Rock and I don't get the explanation. Okay, so let me use this particular slide to explain to us the Reservoir Rock and okay, so I will just tell us the different types of rocks. From the different types of rocks, you'll be able to know, okay, which of them can be classified as a particular rock and which of them cannot be classified. So for the industry, we have different classifications of rocks because all these rocks give us the opportunity to know which of the rock is to be paid more attention to. So we have the igneous rocks, we have the sedimentary rocks, and we have the metamorphic rocks. In the oil and gas industry, majority of our concerns are on the sedimentary rocks because these rocks are permeable. All these rocks are easy, like they are broken off from existing rock. So all these rocks, they have porosity, they have permeability, just like your sand. If you hold your sand, you feel a sharp feel of the sand. And because the sedimentary rocks are more like they are chemical and organic rocks. So it's easier to have deposition of hydrocarbons in sedimentary rocks compared to metamorphic rocks. And one of the examples of the sedimentary rock is the sandstone. The sandstone is an example of the sedimentary rock. So these are the different types of sedimentary rock. This is the sandstone, this is the shale, this is the siltstone. Sorry, I don't know where I pressed. This is the siltstone and this is conglomerate. So for the sandstone, it's different from shale. Sandstone has a little bit more of porosity and permeability, but shale does not have more of interconnected pore spaces, which is porosity. You understand? Who has the question again? Yeah, quadrate. You understand? So rock and the source rock, reservoir rock and the source rock is the source rock usually do not have permeability. Sorry, do not have porosity. Can you hear me?
Yeah, we can hear you.
Okay. So that is one of the major difference between the sandstone and the source rock and the reservoir rock. So the source rock gives us porosity. The source rock gives us permeability. The reservoir rock gives us permeability. The reservoir rock gives us porosity. That is why we always love the reservoir rocks compared to the source rock. So for example of the sedimentary rock, we have for the sedimentary rock we have shale. We have shale, we have gypsum, we have more like coal. But sorry, not to confuse you, I'm coming. I want to check a particular. Yes, look at it here. So for the source rock, they are fine-grained sediments. And the source rock, they are rich in mud. The source rock also are a major factor in the generation of petroleum. I told us in my previous discussion that it's the source rock that generates the hydrocarbon, the source rock. But it's the reservoir rock that holds the hydrocarbon, like it's a storage space for the hydrocarbon, while the source rock is the production space for the hydrocarbon. So it is when heat is acted upon the source rock that it generates the hydrocarbon. While the reservoir rocks, they are porous and they are permeable. Porous means they have holes connected to them, like your sponge. If you press your sponge, let's say a foam, if you press the foam together, whatever that is in that foam will be released out. But if you can't press stone, you cannot press stone because there's no way you will press stone. So that is why the reservoir rocks are porous. Permeable means they allow fluids to flow through them, like they have connections that makes them to have fluids to flow through them. So I hope I was able to explain the source rock is not porous. Source rock is only permeable, but it's not porous. It's not porous because it does not have space. Like it does not have pores, it does not have holes. It does not have holes or punctures. Let me use it that way. Omolade, I hope I did not confuse you further. Then Quadri, I hope I've been able to explain the different, to tell you more about the reservoir rock. Is it clear? Okay, thank you, Quadri. Then the next question that is here is, how do geologists confirm?
I think
Okay, go ahead. Yes, the source rock is
I think there's one question from
okay.
yeah
The
from
next question,
Molade.
right? Okay, you mean the source rock. Omolade, can you unmute and maybe speak so I am sure of what I'm saying?
Okay, sorry, ma. You said the source rock is you said it's not porous, right? That it does not have holes, but it's permeable, meaning that it can allow liquid to pass through it, right? And that is where the hydrocarbon is formed. So
Yes.
if it is not porous, how come it can still retain the hydrocarbon before it moves to the reservoir?
Okay. Thank you for that question. So for the source rock, when we say something is permeable, it means fluids can flow through it, and at the same time, it can. I hate distraction. And at the same time, it can maintain its nature with the materials that are in it. So when we say something is permeable, it means something can withhold, like it's very stingy. Let's say yes, it's very stingy. Like it's difficult for something for it to give out something that is permeable. But if it is porous, porosity and permeability actually works together. But in a state where there is no porosity, there will be another means that will make that particular rock to release its hydrocarbon. And that is where the fault comes in, more like that that line that cut between the different formations. I'm not sure. Okay, yes, let me use this one. Sorry, let me use this image. So now this fault here, this is a fault. This yellow line here is a fault because it has deformed the formation. So the migration can easily take place through this fault. Okay, look at what will happen then. I will just send a record, a voice note on the major difference between the source rock and the reservoir rock, and also tell us the characteristics, what makes a reservoir rock, and what makes a source rock a source rock. I will do that. Let me just turn it here so I don't go further with confusion. Is that okay with you? Okay, thank you very much. So I will answer the last question, and that is, how do geologists confirm a source rock has reached the right maturity level before drilling? Very good question, because we don't want to start drilling from a very So we don't want to drill from an immature basin or an immature source rock, or maybe a reservoir rock. So geologists, they do a lot of activities. They do a lot of exploration. They do a lot of findings. They are more like, they also know the history of that environment. So for example, in Nigeria, yeah, we have basins in Nigeria known as the Nigerian basins. We have the Niger Delta, we have the Benue Trough, we have the Shad Basin. So all these ones are different basins that the geologists with time have been able to map the age of all these different basins in Nigeria. So the way the geologists usually know which of the source rock has gone through maturity, some of them go through chemistry. Chemistry meaning they will observe the particular environment, and they will have information from that environment and run geochemistry on the rock samples that are received from that region. After several geochemist iterations, they will know that, okay, this particular rock is old enough, or they will also do what we know as the TOC, total organic content. With the total organic content of the rock, we are able to know that this rock is old, this rock is mature, or this rock is not mature at all. So TOC is very, very important in knowing the age of what do I put it now? The age of a source rock. For those that did geology in school, and those of people that had the opportunity to do geochemistry as their project, they do a lot of iterations or iterations on rock samples to know the total organic content of the particular rock. So that is how most of the geoscientists do before they do the wildcat well, to know further information of the subsurface. I hope it is understood. Okay, thank you very much. Okay, do we have any other question? I think I'm taking over my time. IB, have I gone overboard?
No,
Okay, so I think if there is no other question, we can stop here for the night. Then I will drop the other materials for us to just go through. I will drop what we call the OPEC children book. The OPEC children book is very important because it gives the basic knowledge of the oil and gas industry, how hydrocarbon is formed, how we get our petroleum, how we fractionate our hydrocarbon into different our crude oil into different segments, how we also know which of the byproducts that are used for different operations in the industry. So I'll stop here for now. Thank you very much. Over to you, IB.
All right. Thank you, everyone, for joining this night. Thank you, our mentor. Thank you, Mr. Thompson. Thank you, MT, for such a wonderful insight. Yeah, that's a great way to start. I believe we planned a lot, Since many of us are science, yeah, we have science background. I believe we refresh ourselves, we don't use our hydrocarbon, all the alkane, all those things and all those things. When she was teaching us, I was just remembering those days that I would be drawing all those, what is it called now? Just this, you'll be drawing different isomers. You can draw like five isomers. So the teacher will tell you that there are too many more isomers you can draw. That you think deeply. Anyway, thank God for growth. Right, so that's the end of the first section, and our mentor gave us an assignment. I should write the name of those alkane from first one, that's methane atom, then carbon atom. All right, so should we give a deadline for that? Okay, let's just make it before the next class, yeah. Or do you want to give us a deadline?
Yeah, we can make it this weekend.
Okay, all right. So let's ensure we done the assignment this week. And we've taken our attendance anyway. So attendance is very important. Please. Let's ensure that we come in, can take the attendance anytime. What's the assignment? Wow. So I will share the assignment again in the group. So, and let's also try to ask questions. Some of us, our background is mechanical, our background is chemical. So it's not a time to ask questions. For other guys that they have background now in petroleum and geology, they might easily flow with all these rock, source rock and everything. But for those with a background in chemical engineering and mechanical engineering, these things might look a kind of strange to us. Even as simple as porosity and permeability is might be a kind of strange to us because that's not our background. So please let's be free, like let's be free to ask questions. Like there's not any question that is too stupid. There's not any question that is too simple, right? So let's be free to ask questions. If you ask questions and they feel like it's too simple, it's not simple to them because that's their field, right? Like the mechanicals, like they start asking their own mechanical questions. So that's how it is. So please let's be free to ask our questions. If there's no other thing, is there another verification that we need? Anybody wants anything? Is there anything I not clear with? Is there anything you want to confirm? Is there anything you want to have confirmed? Is there anything I not clear with? Is there any issue? Is there any addition again from our mentor, Mr. Thompson? Do you have any addition before we call it again? All right, if there's no addition, then thank you very much for the first section of the introduction to oil and gas.
Okay. Ivy, can you hear me?
Yeah, yes, I go ahead, sir.
Okay. All right. Thank you, FG. Okay. So, I just want us to get something clear, like what FG is trying to do is to lay the foundation of petroleum itself, oil and gas. Before we dive deeper into its overview and the industry at large, we need to know what we are talking about. And for those of us that are not from petroleum engineering backgrounds, I know that some terminologies might sound alien to us, might sound very new to us. So I just want us just to, you know, go over them, try to get the meanings of those terminologies. By that way, it will make it easier for us to, comprehend the class as a whole. So what we are talking about when she was talking about uh, the porosity, permeability, the source rock and the reservoir. Uh, the source rock is porous and not permeable. There's O in it, but they allow something they flow anyhow, like it degenerate, you understand? Now the reservoir now we can hold down. Now let me go back to fishing. I believe you can't hear me, right? Are
Yes,
we
sir.
good with that? The
Yes, sir.
reservoir, the reservoir holds it, a trap or a cap, help us to keep it in place, help us to keep it in place so that we'll not be able to get it when we are drilling after our exploration, after the geologists have, help us to map out the area where they believe there is oil. So, so to further enhance our understanding, I want us to go back. Those terminologies that are new to us, get their meanings, and then go over the material again. And if there's any subsequent question before the next class, you can just drop it. You can just drop it to me or to Madam FT. Then we'll clear uh, I would like to say misunderstanding now, or I just have to make it clear, sha. So that's it.
Thank you so much, sir, for the wonderful addition. So please let's stop our attendance before we move to group. Just check the comment section. If you not put your name, please kindly edit and put your name. Or you so kindly please just drop your name. There's attendance going on in the comment in the chat box. Just edit, fix your name, edit, fix your name. We have 4 people who have done that. So please, in the next 30 seconds now, we end the call. So ensure you do that for 30 seconds or less. Thank you very much. 29 seconds more. You have 30 seconds, just edit and drop your name, then we can end it. So please let's go over this thing again. Let's rehearse it. People may have learned, right? I don't have a background in all this. I'm chemical engineer, right? So all this rock of the thing. So please let's go over, let's read and let's digest it. We have 6 people already. We have 7 people already. If not drop your name, please kindly do so now. Alright, we have 1, 2, we have 7 already. I think that's 7, yeah. I think we should go up to 9. So we need 2 people more.
Okay, so I will have to leave to the next class. Thank you very
No
much,
problem.
and we'll see you on our group chat.
Thank you so much for your time. We really appreciate it.
So you stop the recording from your end.
Alright, just stop. We're done, man. Alright, bye everyone. Thank you very much.
Good night, everyone. I see you on Monday.